Hi, for this video what I want to do is I want to talk to you about a perfect square trinomial. This is one of those properties that I see a lot of mistakes that students make, especially when going from this form to this form. I have a lot of students that when they see a plus b squared, they just automatically think it's a squared plus b squared. And this doesn't work. So that's one of those things that it's a very, very common mistake that I see, especially when going from this form to this form. I find that most students just use traditional factoring rules to be able to factor and break it down, but if you can recognize it, it is a shortcut. Okay, so the reason why this becomes this is that if I take a plus b and I'm squaring it, whenever I'm squaring it, that means that I have to take a plus b times a plus b. And so then if I use the traditional foiling method, I would take a times a and a times b. So I end up with a squared plus ab, and then I would multiply the second number in. So I would have b times a, which is the same thing as ab. It's just best to write alphabetically. That way you know that you recognize that they are the same, plus your b squared. And so you can see that we have a middle term here, and this is what I left out up here, and that's what a lot of students do. So I always try to get the students that I currently teach to not make that mistake and to recognize that you always are going to have a middle term. Okay, so don't forget about this middle term right here. It's super important. So I have examples both for factoring and multiplying or finding the product. These are things that will show up, and it can show up in both forms. So if you are dealing with factoring, what you're going to look for in order to recognize this is you're going to look at the first term and see that this is really a squared. And we're going to look at the last term and see that this is really 7 squared. Okay, so then if you look at just the base, the 7 and the a, if I multiply those together, I get 7a, and I want to see, is it double? Well, we see that negative 14 really is negative 2 times 7a. Okay, so that's what we're looking for here. Like I said, sometimes I find students, they would rather just factor it, and they would rather look for two numbers that multiply together to give me 49, that add up to be negative 14. That works too with factoring. So with this, we can just go directly to saying that, okay, since this is a perfect square, this one's a perfect square, and this was twice the product in the middle, I can say my answer is just a minus 7 squared. Okay, so the difference between these two, just to go back here, is that if you have a plus b squared, you end up with a positive middle term. And if you have a minus b squared, then you end up with a negative middle term. So I didn't really discuss that up here, so that's why I put the negative here, is because I saw that my middle term was negative. Okay, so let's look at another example. This one's a little bit harder. For this one, we can see that the middle term is positive. So if either of these rules apply, it would be the first one, since we do have a positive value in the middle. And so we want to look to see, is this a perfect square? Well, yes, 25 is really 5a squared. And my last term, the 36, is really 6 squared. So my other test to see is 60 found by doing 2 times 5 times 6. Okay, and so if you look at it, 2 times 5 gives me 10, 10 times 6 does give me 60, so it meets the criteria. So I could go directly to this one and say, okay, this is going to be 5a plus 6 squared. You do have to recognize the perfect squares in order for this to work. For this one especially, if you recognize that this breaks down, this is a really hard one to factor just by guess and check. So if you know this rule, it does make it easier for you. Okay, and then for the last ones, I'm just going to use the rule, but if you need to, you can always show out the work like I did up here. So it's always okay to show out the work like this. Just don't forget that when you are squaring it, that you do have a plus b times a plus b, and don't make this common mistake here. Okay, so for this one, because I'm just trying to emphasize the rule, I'm going to take and I'm going to apply it. So I square the first term, so 5x squared would give me 25x squared. The third term is just going to be squaring the other value, the 9, and then we want to make sure that we don't forget that middle term. So to get the middle term, we just take 3 times 5 times 2. So if I take 3 times 5, I get 15, and I have 2 of them, so I just double it. So I would end up with 30x in the middle. Okay, so using the rule, I square the first term, I square the last term, that gives me my outside 2, and then the middle is always twice the product of these two values. Okay, so if you want to, you could pause the video right now and try the next one on your own, and then check to make sure you got the correct answer. So if you did pause it, let's check to see if you did it correct. So remember, we square the first term. So we're going to take this square and we're going to plug it in there. So 3x squared would give us 9x squared. We square the last term. So since we have -2 times -2, we do end up with a positive 4. The only sign that is negative is going to be our middle term. And so if we look at this, we would do twice the product. So 2 times 3 is 6. And then if I double it, I would get -12. Okay. So the most important thing with this is to remember that when you're multiplying and you're squaring, that you can't omit that middle term. And like I said, I see that mistake so often in my classes over and over again. No matter how many times I say it, I still have students that do it. So hopefully that will help you to remember that when you are squaring a binomial, you do have to take that binomial times itself, and don't forget your middle term. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you would like for me to cover, please let me know that as well.